Hi, my name is Manish Gupta, and in this video, I'm going to talk about an introduction to a framework called as LangChain. So what is LangChain? LangChain is a framework for developing applications powered by large language models. LangChain consists of these popular modules: models, prompts, memory, indexes, chains, agents, and callbacks. In this video, I will provide a basic introduction to coding in LangChain and also talk in detail about these particular modules. So let's get started. Models. So LangChain supports three different kinds of models: large language models, chat-based models, and text embedding models. Large language models take input as a string and output and also output a string, right? Chat models take input as list of chat messages and output a chat message. Text embedding models take input as text and output a list of floats, that is embeddings. Now, LangChain actually supports integration with a very large number of APIs which provide large language model access. For example, Azure OpenAI API or Hugging Face Hub API or even the OpenAI API. Chat models, well, we will look at chat models, but I think first let's look at a Jupyter notebook, which explores how you can use large language models using LangChain, large language models using LangChain using the OpenAI API. So let's quickly look at this. To use LangChain, first you need to do a basic setup. So set up your OpenAI API key and then include it here. Next, you have to install a whole bunch of packages. First, install LangChain, then install OpenAI, and then install a package called as tick token. So if you are not using Hugging Face API, you don't need to install Hugging Face Hub. Next, so as to use the OpenAI API, you must import OpenAI and then create a constructor of OpenAI and access to the large language model API using this call to OpenAI. With the appropriate model name passed in as a parameter. Here I've passed text damage 003. And then, whatever is your input prompt can be passed to the call to LLM. So tell me a joke, and then, well, there is an output that comes from OpenAI. Okay. You can actually also pass multiple inputs. So maybe you want to pass 4 different inputs. So you can pass all 4 of them by using a function called as llm.generate. And then it returns results for all 4 of them together. So while returning the results, notice that it just does not return the generation, but also returns other kind of output. For example, how many completion tokens were generated, how many prompt tokens were there in the prompt, total tokens, and which model was used to generate the output. You can just print the generations also by looking at the results and just printing dot generations. Next, you can actually print multiple generations. So here, since I have passed n equal to 2, I'm actually able to get multiple generations as well. You can actually also estimate the number of tokens in any particular piece of text string by actually calling getNumTokens function. A getNumTokens in turn uses this tick token. So and that is why, and that is how you can actually estimate the number of tokens in a piece of text. OK, so that's about access to large language models using LangChain specifically for OpenAI API. There are, of course, integration with several other APIs, but I'll leave it to you to explore other integrations as well. Okay. Now, how about chat models? So LangChain also provides access to chat-based large language models. To get access to them, you must import a few things. For example, chat OpenAI. So again, we will be using chat OpenAI API and therefore importing chat OpenAI. And these chat-based models actually, of course, rather than just OpenAI, they integrate with Anthropic, Azure, OpenAI, as well as PromptLayer Chat OpenAI. Okay. There are 4 types of messages that you can provide as part of these chat-based models: AI message, human message, system message, and chat message. Typically, you will always deal with these 3 for the first 3: AI message, human message, and system message. Let's look at an example. Yeah. Since we have to deal with these messages, we should import AI message, human message, and system message. Also, You can deal with these messages in a prompt template format. So therefore, we are also creating importing prompt templates. We'll see how to use them later in this video. Okay. Since we have to use chat-based models, we will import chat OpenAI and create a constructor out of it. So chat OpenAI is an object of chat OpenAI. You can pass a human message in this format. Content, it's human message, and then content equal to translate this sentence from English to French, I love programming. And that basically returns an AI message, which basically contains a French translation of this sentence, I love programming. Okay. You could also pass a message, multiple messages. So you could basically say system message, you are a helpful assistant that translates English to French. And then a human message, I love programming. And then there is a response which comes in, AI message, which is a good translation of I love programming. Typically, system message is meant to tell the chatbot that, hey, the chatbot must behave as if it is a helpful assistant to translate from English to French. And then human message basically takes that into context and then says, hey, now the parameter is I love programming, or the input is I love programming, generate a response to that human message, okay, which is the AI message which is returned by the large language model, chat-based large language model. You can also batch multiple requests and then send a human system message and human message as part of each request. And as a result, the model is going to return AI messages corresponding to each of those requests. Of course, it will also return the typical metadata in terms of how many prompt tokens were generated, how many completion tokens were generated, total tokens, and also which model was used so as to generate this output. In this case, it used GPT 3.5 Turbo, which is the default chat, OpenAI's chat large language model. Okay. You could also use prompt templates so as to pass in these messages. So to create a prompt template, you need to have placeholders. So you are a helpful assistant that translates from some language to target language, input to output language. And then you can say that the system message prompt is going to use system message prompt template with this template string. So from this template string, create a template. Similarly, human text can just be a placeholder text, and you can create a human message prompt template out of the string. A chat prompt template is essentially created from the system message template and the human message prompt, as a combination, and that gives you the chat template. Now, to be able to call the chat model, you of course make a call to the chat model, but with the appropriate chat prompt passed in the right format with the proper parameters. So input language is set to English. Output language is set to French, text is set to I love programming, and then you convert the to messages and then send these messages to the chat model. You get from the chat bot, large language model, you get an output AI message, which is what is printed here. These kind of conversations can also be combined together into a chain, which is called as the LLM chain. So notice that I have imported LLM chain at the top. So from LangChain, not just import prompt template, but also import LLM chain. So we'll talk about chains in a little more detail later in the video. But the idea is that you can actually, for the chain, you must specify what is the chat LLM, what is the LLM that you're going to use, and also what is the prompt that you're going to use. So once you specify that and you create a chain, you can say chain.run and pass in the appropriate parameters for it to actually start running the chain. Okay. And you get the output as the chain is run. It turns out you can actually also do streaming with prompt templates. So or streaming in chat-based scenario. So for example, for streaming, you can basically import streaming standard output callback handler. And then you can actually call call chat OpenAI constructor saying that streaming is true, and then set the callbacks to streaming standard callback standard output callback handler. And then when you pass in the human message, write me a song about sparkling water, you get the response, but then this response is streaming in nature. In the sense, when you run it, you will see this output rendering character by character rather than getting rendered all in one go. Okay. So that's about chat-based models that are supported by LangChain. Lastly, let me talk about text embedding models. Well, LangChain supports several kinds of text embedding models. So you can basically pass in text and get embeddings using these kinds of different embedding techniques: Cohere embeddings, OpenAI embeddings, TensorFlow hub embeddings, sentence transformer embeddings, and so on. So using embeddings is pretty simple in OpenAI. You have to, of course, install the tick token package, and then from LangChain.embeddings import open embeddings, create OpenAI embeddings, and then call the constructor, create an object of OpenAI embeddings, pass in a text document, and say embed query that gives the query result. And you can also say embed documents, and just pass in these documents, get the documents. So you can pass it on as if you're embedding the query or the document, and you can of course print these outputs. So you can actually, for example, here, when I try to print the embedding for the test document, I actually get an embedding. There's a large vector, so large vector with numbers, positive numbers, negative numbers, and so on. And well, OpenAI embeddings, the standard size is 1536. So that's basically what you get when you call this particular, when you try to get a document embedding from OpenAI. Okay, so the next module is prompts. And for these things, I'm not going to go too much into detail. This is an introductory tutorial on LangChain. So for more details, you can actually look at this website, which provides a detailed description of each of these modules. So remember, we're talking about models. So we're done with this, but we'll talk about the remaining modules as well. Prompts is yet another module. We already looked at this module. So prompt template is responsible for the construction of prompts, and lots of people these days do prompt engineering. LangChain just makes prompt engineering very, very interesting and easy. In fact, LangChain supports prompt management, prompt optimization, and prompt serialization as well. LangChain supports large language model prompt templates to prompt language models, and also chat prompt templates to prompt chat models, as we saw in the examples. What we didn't see is how do you decide examples that can go as part of prompts? So, it is well known that, if you include examples, then you get better accuracy from these large language models. So how do you decide these examples? Well, there are example selectors in LangChain. So these examples can be hard coded, but then it is a good idea to dynamically select them. And there are multiple example selectors. 4 of them, I will describe them here. So there's a length-based example selector, maximum margin relevance example selector, n-gram overlap language example selector, and a similarity example selector in LangChain. So the length-based example selector is interesting. It selects which examples to use based on length. So it is useful when you are worried about your prompt size. So remember, all of these APIs actually charge you with respect to the size of the prompt and the output size, and therefore you might want to control the overall size of your prompt. So for longer prompts, the length-based example selector will select fewer examples to include, while for shorter inputs, it will actually select more. Maximal margin relevance example selector selects examples based on a combination of which examples are most similar to inputs, while also optimizing for diversity. So therefore, it selects relevant examples, but while being diverse. It basically uses the simple notion of diversity. Find examples with the embeddings that have the greatest cosine similarity with the inputs, and then iteratively add them to the selected set while penalizing them for closeness to the already selected examples. The typical way you impose diversity when selecting a set of items in a list. The n-gram overlap example selector selects and orders examples based on which examples are most similar to the input according to n-gram overlap score. So it allows for a threshold score to be set, meaning any example which is below that threshold score will not be included in the set of examples for being a part of the prompt. The last one is similarity example selector. It selects examples based on which examples are most similar to the inputs. It does this by finding examples with the embeddings that have greatest cosine similarity. So similarity example selector just uses cosine similarity with the inputs. So that's that. Now, as part of prompts, what you also sometimes want is to format output in a particular way, the output coming from a large language model. This is done as part of output parsers. So language models and chat models, they output text, but many times you want this text to be structured in nature than just unstructured text. So output parsers are responsible for instructing the model how the output should be formatted, and also for passing the output into the desired formatting, including retrying if it is required. Okay, so let me show you some examples of prompts. So to do these prompts, as you see, from LangChain.llms import OpenAI, and then I've basically also created an LLM, the same text DaVinci 003 LLM from OpenAI. And if I want to use a prompt template, the way I would do that is as follows: from LangChain, import prompt template and also LLM chain. Now, prompt templates, as we discussed, can have, we can basically just use simple prompt template as a constructor, and we can have as many input variables as we like. So for example, this is a template which takes no input variables. Right? This is an example which takes one input variable. This is an example which takes two input variables. So the input variables can be defined as part of prompt templates, while when you are using LLM chain, when you are making a call to the LLM chain, while making the call to run method, you can actually pass in what is the input, what is the value that the particular placeholders like adjective and content should take when you call the chain. So for example, here I'm trying to tell it to trying to tell the LLM to generate a joke. So tell me a joke, or tell me a funny joke, or tell me a funny joke about chickens. Okay. So tell me a joke basically gives you this output. Tell me a funny joke also gives you the same output, but tell me a funny joke about chickens actually gives you a joke about chickens. Okay. Well, so we were talking about output parsers, and yes, there are several kinds of output parsers supported in LangChain. So for example, comma separated list output parser generates a list which is comma separated. Pydantic output parser. This output parser allows users to specify an arbitrary JSON schema and query LLMs for JSON outputs that conform to that schema. Okay. So you may tell that, hey, I want I want to basically output movie as an output, and then we should have a movie name, and then maybe movie star cast and the year in which it was released. Okay. And then it basically takes the output from LLM and ensures that it can sort of force the LLM to output in that structured schema. Output fixing parser. Now you can tell the LLM to actually output results in a particular format, but the LLM may not really output results in that format. So therefore, there's an output fixing parser which uses an LLM to itself fix the output that might have incorrectly produced incorrect formatted output. So you can pass the misformatted output along with the format instructions to the model and ask it to fix it. Okay. However, not always this fix works. So for example, in cases like incorrect, when it's not just incorrect format, but also partial response, you can't ask an LLM to sort of fix an output that an LLM gave earlier. So in those cases, what you do is to retry. So retry output parser passes in the prompt as well as the original output to tell the LLM to try again and generate a better response that conforms to a particular kind of output, structured output. Okay. Lastly, there is a structured output parser, which can define structured output without using a class, which is typically used when defining a Pydantic output parser. So that's about prompts. Now let me talk about the third module called as indexes in LangChain. Indexes are ways to structure documents so that LLMs can best interact with them. Let's say if you have a document and you want to build a question answering system based on that FAQ document. Let's say if you have a FAQ document, frequently asked questions kind of a page, right? And you want to have your LLM to act as a chatbot on that FAQ page. The way you would do that is as follows. You would basically take that document, index it appropriately into a kind of an index that we'll talk about, right? And then when a user query comes in, you would want to figure out, which of those questions in your index best matches with the user query, and then return the response based on that. Okay. So maybe what you would do is to have a retriever retrieve the most relevant questions and then pass them as a part of the prompt to the large language model and decide what the right answer should be. Okay. So indexes are ways to structure documents so that LLMs can best interact with them. The most common way that indexes are used in chains is basically in a retrieval step. As I mentioned, given a user query, you might want to retrieve the best matching sentences, let's say from a document, and then use them to generate a good answer to the user query. The retrieval step refers to taking a user's query and returning the most relevant documents. It could refer to most relevant documents. It could refer to most relevant paragraphs or sentences and so on, depending on whatever you index. The primary index and retrieval types supported by LangChain are currently centered across around vector databases, which basically means that the indexes in LangChain essentially take the documents and index them as embedding vectors. Okay. So therefore, there are several things which have to be supported now in LangChain. First, it is document loaders. So given a document, LangChain should know how to load it. Text splitters. So given text, how do I split the text? So what is the unit that I want to index? Vector stores. So, once I have a vector representation of a document, how do I store it? Where do I store it? Right? How do I efficiently store it? And then retrievers. Once I have a query and a database of vectors, how do I retrieve the k nearest neighbors? Right? So those are the different components. Let's talk about them one by one. Document loaders. The idea is how to load documents from a variety of sources. So these sources could be text. So LangChain supports loading documents that text, PowerPoint, images, HTML, PDF. In fact, LangChain supports 73 different document loaders, including these kinds of things. AWS S3 support, Azure support, Google Cloud support, Google Drive, Microsoft OneDrive, CSV, JSON, Microsoft Word format, PowerPoint format, Pandas data frame, PDF format. Even social networks, Reddit, Slack, Telegram, Twitter, WhatsApp chat, YouTube transcripts. LangChain supports all of them in that sense. So great support for loading various formats of documents. LangChain also supports interesting text splitters. So the standard one is, of course, character text splitter or spacey text splitter or NLTK text splitter, but there are also other kinds of splitters like Python code text splitter or LaTeX text splitter or Markdown text splitter. LangChain supports various vector stores, including the most popular ones like FAIRS or Elasticsearch and AnalyticDB, so as to store these vector embeddings for different pieces of text. Lastly, for retrieving, the LangChain supports multiple retrievers, including Elasticsearch BM25, which is the most popular, relevance score computation method, KNN retriever, TF-IDF retriever, so as to essentially retrieve the most similar documents given an input query. In fact, these retrieved documents can be passed as additional context as part of prompts. That is how indexes are used, typically as retrievers in LangChain. LangChain also supports chains, of course, as the name says, right? So using an LLM in isolation is OK. A large language model in isolation is OK for some simple applications. However, for more complex ones and more typical ones, you will require chaining large language model requests, either with each other or with other experts. So there could be other things that you want to combine with large language models, and that can be done using chains. Chains allow us to combine multiple components together to create one single coherent end-to-end application. Okay. Now let's talk about agents. So agents are in fact the piece of the main important module of LangChain where the logic of the application lives. So if you're building an end-to-end application, agent is where you're going to define the logic of the application. Yeah. Now, some simple applications will require, will not require a very complex agent, but more realistic or real-world applications will require not just a predetermined chain of calls to LLMs or other tools, but potentially an unknown chain that depends on users' input. So if you have a very, very simple task, then you can predetermine that, hey, yes, for example, if you want to just scrape some pages from Reddit, then you would want to, you can define a LLM chain that, yes, I must first get some, given a URL, I must just get the URL content, then essentially from that build some rules and say that, hey, this is how I'm going to extract stuff from the web page and so on. Okay, so simple applications like that can work with just a single LLM chain. However, more complex applications require calling appropriate tools and appropriate modules, so to say, based on the user's input. In these types of chains, there is an agent which has access to a suite of tools. So imagine you have lots of tools at your, at your disposal, and you want to use the right tool depending on the user input. Okay. So depending on the user input, the agent must decide if which of the tools it should call, if at all it wants to call. Okay. So the high-level pseudocode of the agent looks like this. Okay. It's a while loop. It's a continued while loop. It continuously keeps listening. So in that loop, it does the following. It waits for some user input. As soon as the user input is received, the agent decides which tool, if any, to use and what the input to the tool should be, the parameters to be passed to the tool. We will talk about the tool soon. Okay. This tool is then called with that tool input, and tool output is recorded. Now that history of the tool input and tool output is passed back into the agent and decides what steps to take next. So this agent, of course, can also be a large language model, right? So it basically then decides what to do next. Now this is repeated until the agent decides it no longer needs to use a tool, and then it responds directly to the user. So when is the while loop broken? Well, it is broken when the agent feels that it has all the required output, and then it directly responds to the user. So the agent is where the logic of the application lives. Agents expose an interface that takes in the user input along with a list of previous steps the agent has taken, and it returns one of the two things. agent action or agent finish. Agent action basically means that continue the while loop, right? It corresponds to the tool to use and the input to be passed to the tool, right? While agent finish basically means end the while loop, and it means that the agent is done and the information is ready to be passed to the user. Okay. Now, what are tools? Tools are basically actions the agent can take. So we will see in the next slide what are the different kinds of tools that LangChain supports. Very interesting tools. What are toolkits? Well, toolkits are groups of tools. So that are required for a specific use case and that the agent must have access to. So for example, if you're building an agent to interact with the SQL database, it may need access to tools like executing queries, inspecting tables, deleting tables, creating tables, and so on. Okay. And then, yet another part of the agent framework is agent executor. This basically wraps an agent and a list of tools. And this is responsible for the loop that we've been talking about here of running the agent iteratively until agent finish is returned by the agent. Okay. So what is an agent in general from programming paradigm perspective, right? So agent essentially consists of a prompt template, a language model that it can use so as to essentially decide which tool to use and what parameters to pass to the tool depending on the user query, and also to decide whether it should basically say agent action or agent finish. Yeah. And it also has an output parser, which takes the output of the large language model, this particular large language model, and parses it into an agent action or agent finish object. Okay. Now, LangChain supports a large variety of tools, as you see here. Some of them are search tools, some of them are shell tools, Python tool, various APIs as tools, Wikipedia, knowledge graph as tools, and so on. So LangChain actually supports a large number of interesting tools. In fact, it also supports ChatGPT plugins. So it supports ChatGPT plugins also as tools. Next, let me talk about the memory module. So of the various modules, remember we have talked about several things like models. We talked about models, we talked about prompts, we talked about indexes, and we talked about chains. And lastly, we talked about agents. Now, next, let's talk about memory. So, well, we've talked about chains and agents, and they are both stateless, meaning that they treat each incoming request, each incoming query independently. Underlying large language models, which are part of these LLMs and chains, or chat models, whatever they may be, are also stateless. So in some applications, however, what you want to do is to have a persistent memory. You want to persist state. For example, in chatbots, it's important to remember previous interactions, sometimes in a short term, sometimes long term level, right? So memory is basically the concept of persisting state between calls of a chain or an agent. LangChain actually provides helper utilities for managing and manipulating previous chat messages, for example, in a chatbot scenario. LangChain also provides easy ways to incorporate these utilities into chains. So when you're creating chains, how can you basically take the output, store it to the memory, retrieve from the memory? So all of those operations are supported in LangChain. It involves ingesting, capturing, transforming, and extracting knowledge from a sequence of chat messages. If a list of chat messages coming as part of the chain, as outputs or inputs, how can you use them to manipulate the memory? Memory, can return multiple pieces of information. For example, it could return most n messages from a chat conversation, or it could actually return a summary of the previous n messages, and so on. So this return information can either be a string or a list of strings. Therefore, if it's a summary, it's just a string. If it's like previous n messages from the conversation, which you want to incorporate as additional context in your next call to a large language model, it could be a list of messages. Okay, so lastly, let me talk about this module that LangChain supports called as Callbacks. And Callbacks, as the name says, it's basically more for logging and monitoring. So, and of course, it can be difficult to track all of that, whatever happens inside a chain or an agent. And callbacks can actually give you a level of observability or introspection, or in simple words, call it as debugging. Right? So callbacks allow you to hook into the various stages of your large language model application. This is useful for, of course, logging, monitoring, streaming, and other kinds of tasks. Now, LangChain support two kinds of callbacks, constructor callbacks and request callbacks. Now, as the name says, for both of them, they're associated appropriately. So, for example, constructor callbacks are associated with an object. So they are used for all calls made on that object, while request callbacks are associated with a specific request and, of course, all the sub-requests of that specific request. Constructor callbacks are most useful for use cases such as logging, monitoring, etc., which are not specific to a single request, but rather to the entire chain. Of course, the chain can consist of multiple requests. Okay. Request callbacks are most useful for use cases such as streaming, where you want to stream the output of a single request to a specific WebSocket application or a WebSocket connection. Okay. So that's that. So let me quickly summarize what we learned in this video. We talked about LangChain. LangChain is a framework for developing applications powered by large language models. And in this video, we discussed these following important modules in the LangChain framework: models, prompts, memory, indexes, chains, agents, and callbacks. If you want to learn more about LangChain, have a look at these pages. This is a very good documentation of LangChain in Python. And here are some really nice tutorials with end-to-end use cases also supported using LangChain. OK, so that's it. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.